Hello, and welcome to Calculus Problems Explained. I'm Jacob Cherry, and today we'll be working on the released 2015 AP Calculus BC free response question number 2, which is shown on screen here. At time t equals 0, a particle moving along a curve in the xy plane has a position x of t, y of t, with a velocity vector v of t equal cosine of t squared, comma, e to the power 0.5 t. At t equal 1, the particle is at the point 3, 5. A, find the x-coordinate of the position at time t equals 0, 2. B, for 0 less than t less than 1, there is a point on the curve at which the line tangent to the curve is a slope of 2, blah, blah, blah. C, find the time at which the speed of the particle is 3. And D, find the total distance traveled by the particle. So, we're going to start by moving this over here. And let's get started. All right. So, A, the x-coordinate of the position of the particle at time t equals 2. Well, we know that x of t is equal to x of some constant a plus the integral from a to t of v du, because position is the integral of velocity, right? So from here, you can apply that like so. If you take your thing and you say, oh, x equal the value of x at t, where t is 1, you can say that x equal to 3 plus integral from 1, because that's t, to, well, what do we want? We want 2, because that's the time we want. And then v of x, so v velocity in the x direction, is going to be our cosine of t squared, like so. Cosine of t squared dt. So we can simply evaluate that. We plug it into our calculator. So here we have our calculator over here on the right. You can see it as a box in the top right of the screen. So let's go in and let's plug stuff in like that. So you're gonna type 3 plus math 9, 1 right, 2 right. So that gives you kind of that number right there as soon as it loads. Okay, so it gives you that, right? So you've added your 3 there, and your interval of, or limits of integration. And so what you want to do from there is you want to go and type in your cosine of t squared. So I'm just going to use x because it's easier for me. I just one button as opposed to two. Just make sure your your d variable is the same. So that gives you this screen right here, right? Okay. And then if you hit enter, it'll give you the answer that you are looking for, which will pop up in a sec. There. So it's going to be your 2.556 blah, 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 blah. Now, since this is the calculator portion and we've used our calculator to answer that question, let's make the answer 2.557, rounding to the nearest third decimal point. Let's make that slightly smaller. Right. And so you have there your answer for part A. Right. Cool. Part B says the following. Part B says, for 0 less than time less than 1, there is a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? Well, line tangent means that your dy dx has a slope. Oh, look, has a slope. So that's equal to 2. Well, everything is in terms of t. How can you therefore get dy dx? Oh, look, dy dt over dx dt. And the dt's cancel. Cool. Well, what is this right here? This dy dt is going to be this up here, your e to the power 0.5t. Why? Because velocity in the y direction is equal to your derivative of y. Okay, cool. Same with velocity in the x direction. That's the derivative of your x. Sweet. Now we've got a nice, easy way of telling what this value right here is. And it is, as will be shown, this is your dy dt, which is e to the power 0.5 t over cosine of t squared. Cool. So now all we have to do is set that equal to 2. Well, you can move the bottom to the top by doing e to the power 0.5 t equal to 2 cosine of t squared, right? And then let's go ahead and use our handy dandy calculator. Because we have stuff, let's go ahead and clear that and go to catalog, which you can do by second 0, and then hitting the 4 key to go to the t's. Then you can scroll up until you reach solve. I prefer that method because I think it's faster than going down for it. Hit enter, and then type your equation that is equal to 0. So to do that, you want to subtract one side from the other side. 2 cosine x squared minus e to the 0.5 x, and that'll give you, that's just that part. In addition to that, you need to type the variable you're going to use, comma, and some guess that seems reasonable. I'm just gonna put 0.5 because it's halfway between the two times. And then close parentheses, and then hit enter. And it solves it for you, giving you a value of 0.840. Since you have the calculator for this portion of the exam, why not use it? If it's going to solve it for you, let it solve it for you. You have to know all the calculus here anyways. So let's go ahead and write that in. T equal 0.840, and box it in because you're done. And now part C. Part C says, find the time at which the speed of the particle is 3. Well, speed is the absolute value or the magnitude of velocity. Velocity is a vector. That means that when you move with a velocity, you not only have a speed, but you also have a direction. That's very important because what it means is the speed you can get by determining what the magnitude or absolute value or whatever of that v is. So you can say that speed equals to absolute value of velocity. Right. So, that being said, what you would do now is you would go in and would say, oh, you want to know when the speed of the particle is 3? Let's do that. 3 equals. Easy. Now to get the magnitude of a vector, you want to plug it into the distance formula. Now don't get this confused. The distance formula, in other words, square root x minus a squared plus y minus b squared, blah, blah, blah. That distance formula does not mean this up here, position. It's not that. What it is simply a way of describing the magnitude of a vector All you really need to know is, in order to find a scalar that is the magnitude of the vector, all you got to do, apply the distance formula. How do you do that? Square root. What's x? X is cosine t squared. I'm an x component. Square that plus e to the 0.5 t squared and all in the square root. Oh, look. Got yourself another one of them pesky solvable equations. How do you solve one of these? Simple. Catalog, solve, just like you know how to do. Let's go ahead and type in the equation, which is like so. Cosine of x squared plus e to the 0.5 x squared minus 3 . And now you want to type comma x comma 0.5 because you want to find a time between the two. Put a halfway between, makes it real easy. And then you are going to hit enter. And that gives you an answer of 2.196. And that's it. You're done there. Sweet. Okay, and now for the final part of this problem. Part D says, find the total distance traveled by the particle from time t equals 0 to time t equals 1. Now the interesting thing is we have distance. Now, distance is the length of the entire pathway that it travels, not the position that it stops at. So you can't just find, oh, the derivative of this is this, and the derivative of this is this, and then you can take the integral like we did at part A. Not really. But you can take the integral of speed over the entire time. In much the same way that position is the integral of velocity, at time t equals 0, he's not gone the entire, he's not gone anywhere at all. So we don't have, so whereas you would normally put blah 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 d at time 0, that's just 0. There's no point in doing that, and I just accidentally created an infinitesimally small thing, so I'm going to erase it now. Right, so, but what you do have is you do have this nice integral here from 0, well, I mean, I say nice, it's not very nice at all, because it's the integral of speed. Well, what's the speed? It's the distance formula applied with velocities. Yeah, this mess right here. Okay, so it's not a nice integral, not in the slightest. And we can't do that by hand. That's u subs and e to the power theta I weirdness there. So let's go ahead and just plug into our calculator. This is the calculator section after all. We can just plug it into the same solve function. Now you might as well, well, no, not solve. Math 9. Do Math 9. Math 9 is life. And so you end up with this nice little thing and start filling in your limits of integration. Right? And then let's plug in this thing, just 1 to 1, straight from there. Square root cosine of x squared plus e to the 0.5 x squared dx. Right, so it's literally just the same thing. I've just changed the variables because it's easier for me to plug it in. So let's evaluate that. And what do you get? You get 1.595 as your total distance. That's a decimal point. And there's the last bit, and you're done. That's 9 points. Easy peasy. Now you can do the same thing on the particle motion portion of your exam. Go out and do some good calculus. Woohoo!